So having f of x to be equal to y will be the same as tan x. So we start by coming up with our table. So x, y is equal to tan x. Now for tan, because of its nature, it's always advisable for you to start, and also it's always advisable for you to include the negative part. Alright, very good. And also the interval, you can choose the interval of 45 degrees, and that is going to help you for the graph of tangents. Alright. So we start with negative pi on 2. Sorry, I mean the interval of 90 degrees. So negative pi on 2. Then we move to negative pi on 4. Okay, very good. Then we move to 0. Then we move to 0. Then we move to pi on 4 and pi on 2. So you can see that there, the interval we have now is 45 degrees. Interval of 45 degrees. Interval of 20 degrees too will also work, but that one will stretch your graph. It will make it too small. Okay. Now, for you to appreciate the nature of tangent graph, you need to include the negative part. Alright. Even up to this part is okay. So that is that. Let's compute and see what you're going to get. So when you compute, you realize that with this you get undefined. Undefined. You get it to be undefined. That is why you have to include that part. Alright. And also, negative pi on 4, you're going to get a real number, negative 1. Then for 0, you get 0. Then take your calculator, let's do it. What do you get for that? The 1 for pi on 4, that is going to be 1. Very good, 1. And this one, you get undefined. So you see that you get syntax error or math error. That means that it is undefined. So that is that for that. So that's why if you start with 0 and end with pi on 2, you will not appreciate the nature work. But when you start with this, you can see that here is undefined, here is undefined. So let's go for the table. So we have 0 here, negative pi on 2. Then, from 0 we come to negative pi on 4, that is 45 degrees. Then we move to the next 45 degrees, which is going to be 90. So from here to here is 80. So but here to here is 45, here to here is 45. Then we move the same thing for this. Pi on 4, then pi on 2. Very good. So now watch. When we have it to be undefined, then it is going to be asymptotic at where x is negative pi and at where x is pi. So the graph is going to be asymptotic to this. That is asymptote. That is that. Very good. Then at negative pi on 4, we have negative 1. At negative pi on 4, we have negative 1. So let me. The minimum is negative 1 and the maximum is 1. So that is that. So at negative pi on 4, we have negative 1. Then at pi on 4, we have 1. So the nature of this graph is somehow like this. So this one should move to this direction. What we can see that this one will move to this direction. Now it will get closer to this, but it can never cross it like this. Alright? Hope you can remember your asymptote also. Oh, let me see if you see, it's not according to scale, so sometimes I didn't mean for that. Very good. So we get it like this. Then to get closer. Oh. Why all this? Very good. Okay. So to get closer, 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 closer. And this one to get closer, 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 closer like that. In fact, if you have a GeoGebra, you can check that on your GeoGebra software and you see that. Very good. So let's take it like that. Let's take it like that. So that is going to be for a tangent graph. That's going to be for a tangent graph. So with this nature, then let's go and look at the properties of the tangent curve. The properties of the tangent curve. Okay, I'll be back with it. Alright, so that is the properties of tangent curve. The first one is that, in case you can see it well, the graph is discontinuous at value of s of the form this, alright? It's discontinuous at value of s of the form s equal to 2n plus 1 multiplied by pi over 2. So that means that we are saying that the n is an integer, so the n can be 1, can be 2, can be 3, can be anything, and has a vertical asymptote. Yeah, you know it has a vertical asymptote. And it's not that it's having a vertical asymptote at only negative pi or 4. Sorry, let me check. Yeah, it's not only at pi on 2 and negative pi on 2. When you continue with it, you can realize that it will be repeating as such. So it has a vertical asymptote, just end it there. 2. Its x-intercepts are of the form, x equal to n pi, x equal to n pi. And 3, its period is pi. Don't forget that the period for sine and cosine is 2 pi. But for tangent curve, that is pi. Please don't confuse yourself with it. This is just pi. Very good. 4. The graph has no amplitude yet because the nature of it is like this. We have an asymptote here, we have an asymptote here, and the graph is like that. So you can see that it has no, because this one will go, but it will never touch this. So it will continue to go like this, this one will continue to go like this. So that is that. So it has no amplitude. When we say amplitude, that is maximum and the minimum. You can't identify the maximum and the minimum of the ring here. So we see it has no amplitude. 5. The graph is symmetric with respect to the origin. The graph is symmetric with respect to the origin. So the function is an odd function. Since it's symmetric to the origin, so the function is an odd function. Don't forget that for sine curve, that one too is symmetric at the origin. I hope you, when you say symmetric at the origin, you understand. That is that. This is the origin. So since it's symmetric at the origin, it is an odd function. So for all x in domain, that means that when you plug in a negative value, you get a negative value back. Do you know why tan s is an odd function. Don't forget that. Tan is sin s over cos. So definitely that is what you're going to get for that. Very good. So where are we even going? Now we have looked at cosine and sine and also tangent. So in our next video, we are going to look at graph of other circular functions. Circular functions, other circular functions, we are talking of the reciprocals of cos, the reciprocal of sec, the reciprocal of tangent, and that is sec, cosec, cot. See you for that video. Alright, so let's look at graph of other circular functions. So we are starting from cosecant. Cosecant. So let's look at cosecant function. So that is a function y is equal to f over n. In short, we say cosec, but the right pronunciation is supposed to be cosecant. Even if you write it as this, you have to pronounce it as cosecant. That is why we have this is sine, but the short form is sin. Why don't you pronounce it as sin s? No, sine. Alright. So this should be pronounced as cosecant. Very good. So let's look at the graph of cosecant. Let's go for the table. So this is what we have for the table. Now for the table, you have to know that cosecant is a reciprocal of sine. Please watch. It's a reciprocal of sine. Don't let anybody disturb you. Focus. Alright. It's a reciprocal of sine. And cosecant is not included on your calculator. So what you have to do is that you know that cosecant is equal to 1 over sine x. Is equal to 1 over sine. So we need to include y is equal to sine x on our calculator, on our table. Then cosecant x, so that the values you get here, you take 1 over 8. That is taking the inverse of the results, and that's going to give you the cosecant. Very good. So let's start with that. And here I'll be including the negative side, the negative value side. Please, it's not compulsory. You can choose to bring, or you can choose not to bring it. Alright, very good. So for the negative part, since this is the general view, I would like to include it. So we start, okay, we start from negative 2 pi, then we move to negative 3 pi over 2. Then we move to negative, after negative 3 pi over 2, then let's move to, or let me take it from, okay, so after negative 3 pi over 2, then we move to pi, pi. Yeah, that is going to be pi. Pi. Then the next is going to be negative pi over 2. Then the next will be 0. Alright. Then for the right hand side, that's going to be the positive side. So then we take pi over 2, then we take negative, we take pi, then we take 3 pi over 2. What we can see from there, that is the last one with 2 pi. Alright. So that you can see clearly. So this is pi, alright? This is 3 pi over 2, and this is 2 pi. Very good. Sorry for that. But I hope you can see. Okay. So that is that. So we are going to do the computation. Now you can see that the difference from 0 to pi on 2. That means that the difference we have here is 90 degrees. 90 degrees. So 0 to 90, 90 to 270. Sorry. 90 to pi. That is 180. Then from 180 to 270. Then from 270 to 360. That is 2 pi. Okay. So let's move on. Alright. Now, take your calculators and let's go. Take your calculators. Alright. Now for sine of negative 2 pi, that is going to give you syntax error or math error. And that is undefined. So you'll be undefined. That means that if you take 1 over the undefined, this will still give you undefined. Alright, so that's going to be undefined. Then let's go to negative 3 pi on 2. Make sure that you are in radian mode. Now for negative 3 pi on 2, you can see that is going to give you 1. And 1 over this is still 1. Alright, 1 over this is still 1. Then let's go to negative pi. Sine of negative pi. That's going to give you undefined. Very good. And the same thing here, undefined. And negative pi on 2. Okay, that's going to give you negative 1. Negative 1. And 1 over this is still negative 1. Then, what of that of 0? That of 0 will be giving you 0. Don't forget that cosecant, since it's 1 over sine, is going to be an odd function. Okay, so it is symmetric at the origin. So there we are going to get 0, 0. For pi on 2, what you think pi on 2 also is going to be, if this is negative 1, here will be 1, here will be 1. Just like that. This is undefined, then definitely this one is going to be undefined. And here is going to be undefined. And for 3 pi on 2, negative 3 pi on 2 is 1. Okay, then here is going to be negative. Yeah, let me check from my calculator. Alright, yeah. So that's going to be negative 1, negative 1. Alright. If this is positive, this will be negative. And lastly, you are going to get that for 2 pi, you are going to get that to be undefined. Undefined. Alright, so since we have our table, we now move to the graph. Draw it nicely. Oh, is it true that this one is true? Oh, let's take it like that. It's nicely drawn. So this is going to be the origin. Then we are going to have how many divisions? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so we have pi on 2, 3 pi, no, from, then we go to pi, yeah, it's 90 degrees, pi. Then we go to 3 pi over 2. Then we go to 2 pi. Negative pi over 2. We move to negative pi, move to negative 3 pi over 2. Move to 2 pi. Negative 2 pi. Very good. Then we know that the maximum number we have here is 1 and the minimum is negative 1. Okay. Let me pick this one downward again. Alright, so the first thing that we have to sketch is for the sun. Is for the sun. Don't, please listen to me well. The first thing to do is for the sun. So we are going to draw for y is equal to sin x. And we now Let's first indicate the asymptote. The undefined, they are all going to give us asymptote. So at negative pi on 2, there is an asymptote there. And for negative pi, there is an asymptote there. And also for what the next 3 pi on 2, we have asymptote. For 3 pi on 2, oh sorry, for pi. And for 2 pi, we have asymptote. So let's first go for the sign. We know how the sign is going to be. Now, at negative 3 pi on 2, we have 1. So that's going to be here. Then, at negative pi on 2, we have negative 1. And that's going to be here. At pi on 2, we have 1. This how we find down. 3 pi on 2, we have negative 1. Okay. So you know it's going to be symmetric at the origin. So to go like this. Wow, take your time. Hope you are doing your own. Do it well. Nice. It's a science step. Then from here to get to the 2 pi. Hope you can see that. Very good. Now, what about the cosec? What about the cosec? Don't forget, that is going to be the reciprocal. You see, we took the reciprocal of it. So we take the reciprocal of this. When you take the reciprocal of this, it's going to be 1 over this. That is the inverse of it. So watch. If you have this and you take the reciprocal of this, okay, it will, okay, this one is open downward. So the reciprocal of this open downward will be open upward, alright? And when it's open upward, don't forget there is an asymptote here. So when it's open upward, it will be like this. Wow, wow, wow. Oh, so unfortunately I don't have a red marker here. I should have made a red marker or any different marker. So that's going to be the reciprocal. So this, what we are doing is actually the cosec. This one is sine. And you cannot successfully graph the cosec without the sine. Alright, without the sine, because that is the reciprocal of it. Very good. Now, this one is open upward here. So what will be the reciprocal of this? And that is going to be this. And since the asymptote is there, you get it like this. I hope it's clear. And this one will be open upward. And that's going to give you this. Alright. And this one will be the same thing. Very good. I hope you can see how nicely it's drawn. So indicate arrow here to show that it is going upward and downward like that. So that is for the cosec. Is for the cosec. But don't forget, you first need to draw. Okay, firstly, indicate the asymptote. Secondly, go for that of sine. Then, lastly, you go for that for the cosec. So we are not interested in getting the sine, but we get used to get our thing. So don't make it block, but make it dotted. Dotted. Nice one. 9 is 1. So no matter the function you be given, if it is cosec, that is how you are going to do it. Very good. What the next thing? You are done with the graph. So the next is probably going to be for the properties. We are going to look at the properties, and we have about 5 properties to look at. 8. Oh, 9. Very good. So please, let's write properties of the cosecant function. Properties. This one is not difficult. 0, pi or 2. It just within degrees interval. But as I said, you can choose to ignore the negative side and use only the positive side. Properties of the cosecant function. Properties of the cosecant function. The first one is that, now watch. You can see that it has a period of it's not pi, it's 2 pi. Don't forget, the period of sine is 2 pi. So the reciprocal is the same thing, 2 pi. So the period is 2 pi. Now, secondly, there are no x-intercepts. We are looking at the properties and looking at this. Don't forget, this is sine. This is for the cosec, right? And you can see that it has no x-intercept. So there are no x-intercepts. There are no x-intercepts. There are no x-intercepts. No not intercepts. There are no x-intercepts. 3. Watch. What can you say, or what can you deduce from this graph? The graph has no. I'm just saying it. What comment can you give for cosecant function for amplitude? Will it have an amplitude or not? Yeah, there is no amplitude. So write no amplitude. Write it well. The graph has no amplitude. The graph has no amplitude. Fourthly, what can you say when it comes to asymptotes? 4. The graph is discontinuous. You know what a continuous function or a discontinuous function is, alright? A continuous means that there is no break or asymptote or hole in plus 1. So that means that, or that is what makes a function continuous. That means that there is no asymptote, there is no hole, there is no break. But with this, you can see that we have an asymptote in it. So the graph is discontinuous at value of s of the form. The graph is discontinuous at values of s of the form s is equal to n pi. S is equal to n pi. Or what can we say? Pi n, the same thing. And has vertical asymptote at these values. And has vertical asymptote at these values. We are saying that the graph of cosecant is having a vertical asymptote at values where n is equal to n pi. See, if n is 1, you get pi, and there is asymptote at pi. If n is 2, you get 2 pi, and there is asymptote at 2 pi. If n is 3, when you continue with it, you will continue. You are going to get 3 pi, 4 pi. Don't pa. That reminds you something. Pa. So don't you. Sorry for me, okay? The SM fans. All right. Pa. So for those 2 pi, 3 pi, pa, you are going to get attention today. Very good. 5. I'm sure somebody wants to know whether I'm SM fan or not. Let's move on. So please don't repeat the 4 again. The graph is discontinuous at values of x of the form x is equal to n pi and has a vertical asymptote at these values. 5. The graph is symmetric with respect to the origin. Is symmetric with respect to the origin. So the function is an odd function, and that one you know already because it's a reciprocal of sign. And the function is an odd function for all x in the domain. For all x in the domain. Alright, so that is all for that. That's all for that. Now we will be looking at that of sec. I'll be back. Alright, so we are looking at that of sec. I know that sec x is equal to 1 over cos. So the reciprocal of cos is sec. Very good. So on your table, we need to include that for cos y is equal to cos x and y is equal to sec hand x. Very good. I'll leave that for you to do it on your own. You can use the same interval we did for the cosecant, alright? That is the 90 degrees interval. So here 0, pi on 2, 3 pi on 2, then 2 pi. Then this will be negative pi on 2, this will be negative 3 pi on 2, then this will be negative 2 pi. Very good. You can do that and compute to see what you are going to get. Alright. Now here you can see that your graph is going to be here is going to be undefined. Do that. Take my calculator and do that. Here is going to be undefined. So, and not only that, and at pi on 2. At 3 pi on 2, you get undefined there. And at pi on 2, you get undefined there. Oh, I exclude pi. Let me use only. Let me include only the first. So 0, pi on 2, pi, 3 pi on 2, and 2 pi. Then the negatives follows like that. So at pi on 2, yeah, at pi on 2 you get undefined there, and at 3 pi on 2 you get undefined there. Very good. So we start here is 0, here is pi on 2, here is pi, here is 3 pi over 2, here is 2 pi. Then the negatives will follow. Negative pi on 2, we have negative pi, we have negative 3 pi on 2, then we have 2 pi, then negative 2 pi. And know that this is going to give you 1, and this is going to give you 1, and that's for this you get 1, and for the pi you get negative 1. I want to allow you to do it yourself, okay? And for this, you also get 1. Very good. And it follows like that. So, when you take 1 over this, you still get 1. 1 over this, you still get undefined. 1 over this, you still get negative 1. 1 over this, you still get right? 1 over this is 7. Please, it's not always that the output for the course is going to be the same as the same. Okay, it depends on the procedural movement. You know that this what you're doing is just at the origin. Very good. So you go for 1 and -1. So as we did in the cosecant, it's the same thing for the sec. Let's first use the cos as our guide. And you know what cos is going to give you. But the undefined, let's look at the undefined. The asymptote is at the asymptote to be here. So let's go for the cos. At 0, we have 1. At pi on 2, we have undefined there. At pi, we have -1. Hope you are following. This is going to be undefined. At 2 pi, we have 1. Okay, so we start from here. So that's going to be the graph for cos. That's going to be the graph. Take it like that. That's going to be the graph of cos. So you can relate the same thing to the one here, okay? And that one you're going to get it like this. Very good. So that's what you're going to get for that. Okay, so let's look at the reciprocal because the set is just reciprocal. So the reciprocal of this side is going to give you this. It's the same as the cosecant, the reciprocal. This open upward, so it will be open downward. This open downward, so it will be open upward. And it is asymptotic. Very nice. Open downward. Now with this, know that it's increasing, then it begins to decrease. Okay, so this one. All right. So with this one, you are going to get it like this. You're going to get it like this. That's what you're going to get it. That's how you're going to get it for that part. So with this, the same thing. Okay. So that is for the code sec. And since, sorry, that is for the sec. And since you are not interested in the course, you do that blocking. Make sure it's nicely sketched. Very good. So let's quickly go for the properties. Let's go for the properties. Let's move on. Properties. So you can see that if you focus on the positive side, then you can get the negative side. The properties. Then after this, we go for the last reciprocal, that is cos. Looking at the properties, the first one is that, let's write. 1, its period is 2 pi, because you know that set is the reciprocal of cos, and cos, the period is 2 pi. So this one to the same thing. So its period is 2 pi. 2. How? What can you say about asymptote here? No asymptote. There is no asymptote because it just going like that. So 2, there are no asymptotes. 3, the graph has no amplitude. I'm confused. Sorry. 1. If period is 2 pi. 3. There are no s-intercepts. 3. There are no s-intercepts. 2. There are no s-intercepts. 3. The graph has no asymptote. So no asymptote, no s-intercept. The period is 2 pi. Let's move on. The graph is discontinuous. The graph 4. The graph is discontinuous at value of s of the form at values of s of the form s is equal to 2n plus 1 pi on 2. So when n is 1, what will you get? You get 3 times pi over 2, and that is 3 pi over 2. That is why it is asymptotic at 3 pi over 2. And when n is 2 to 4, so you get 5 pi, so 5 pi on 2, at 5 pi on 2, you also get 8 to be what? Asymptotic. So it's continuous like that. Very good. So 4. The graph is discontinuous at value of s of the form this and has a vertical asymptote at these values. And has a vertical asymptote at these values. 5. Are you done? 5. The graph is symmetric with respect to the y-axis. The graph is symmetric with respect to the y-axis. So the graph is an even function. The graph is an even function. The graph is an even function. For all s in the domain, for all s in the domain, that, very good. For all s in the domain, that. Okay, so that is all for graph of other singular functions, cosecant and secant. Let's go for the last one, which is cotangent. Cotangent. Alright, so without wasting much time, that's for the cotangent. So that's going to be the interval of the graph. You see, the same as the one for tan. Okay, the interval 45 degrees. Now for tan, it goes like this. In case you can't remember, it goes like this. For tan, it goes like this. So the reciprocal, if tan is going like this, let me show you. If tan is going like this, then the reciprocal will be going like this. I hope you can see that. Very good. So that's going to be that for tan. So it's asymptotic. It is asymptotic at the origin and at pi on 2 and at 2 pi. Very good. So if tan will be like this, then for cot, it will be like this. Nicely sketched. Take it like that. Take it like that. It will be like this. It will be like this. That is going to be that for cotangent. So let's look at the properties and proceed for that. No, let me give you that as an assignment. So for your assignment, you have to go and look for the properties of cotangent and place. I won't tell you. Alright, so that is that. Go and link it to the one for the tan and find out the properties of cotangent. So for your assignment, you have to go and look for the properties of cotangent and place. I won't tell you. Alright, so that is that. Go and link it to the one for the tan and find out the properties of cotangent and place. So for your assignment, you have to go and look for the properties of cotangent and find out the properties of cotangent and place. properties for that. Thank you. See you in the next video. In the next video, we are going to look at more examples, all right? We are going to look at reference number, graph and diag transformation, and modeling real-life situation using curve fitting. So, see you in that video.